So good evening, everyone. I hope I am audible to you. So if you're able to hear me, kindly respond in the chat. We have given a chat option to you, so you can respond in the chat. So can I have some responses in the chat? Yeah, I'm just waiting for a few more participants to join. So once people join, right, we'll start the session. So we'll wait till 6:05. Okay, so we'll wait for 5 more minutes. Once after that, I'll just start the session. Yeah, thank you so much for the response, guys. Yeah. So someone is asking that is there any prerequisite for the class? Yes. So you have to install Docker in your laptops. If not, also it's fine. I'll just show you. Or else you can go to the Docker Hub and register an account. So no issues. In the session itself, I'll be showing you what you all need to do. Okay. So yeah. So meanwhile, the people who have been joined, right? So to save some time in the session, I request you to please go to this Docker Hub. So I'll just share the link in the chat for your understanding. Yeah, I'll explain. Don't worry, what is Docker? I'll explain, but just try to create an account. Okay, so this is a site link I've shared. You can open this in the browser. So you can see, right, a register button over here. Yeah, so click on the register button and just try to sign up for an account. So to make some time efficient, right? So you can go to that link, that is hub.docker.com/sign up. Okay, just open the link and register an account. You will get an email to your personal email. What are the email you give here, right? You will get that email to your emails, and you have to verify that. And I request all of you to create an account in the Docker Hub. You have to use your own emails, Abhimanyu. So I request you to use your own emails. Nirmala, I'll explain. Don't worry. I'm just only asking you to register for now to save some time. As most of the people have been joining, right? I'm asking you to just register an account. I'll explain what is Docker and all this stuff. We also will have the hands-on on the Docker. Okay. So once we get the knowledge, you can use your own email. No issues. There is no requirement of using Smart Intern's email. You can use your own email address to register an account in the Docker. So I request all of you to register. Okay, so once more I'm saying, I will also share this link again in the chat. So meanwhile, the people who have been joined in the session, I request to create an account here. So let me go back to my PPT. Yeah. So before I start, right, I just wanted to ask you that yesterday you are done with the IBM DB2 service, right? So you might have seen the Flask application development. Then later on, my colleague Srikanth has been taught you how to use the IBM DB2 service and develop some Flask application, right? So can I get some response about that? You have done that, right? So if you have done that, we will continue the same today. Yeah, thank you, Nirmala, for that. Guys, can you respond in the chat? Hope you are done with that, right? The Plasma Donor app, what we have been taught you yesterday, and I hope you are done with that application development, right? Yeah. So, yeah, today we will start with what is Docker, right? So I'll explain you what is actually Docker about, and then I'll be showing you how can we make our Flask application into a Docker image. So this is the thing we'll look into that. So first of all, we'll learn what is Docker. Then we'll go for the making our application. Whatever the Flask application you or might be developed yesterday, we will be converting that application into a Docker image, right? Yeah. So fine. So we will now look into our Docker concepts. Okay. So right? So we have a lot of applications are been built from the late 2000s, right? So most of the applications are the web applications, right? So you can see the graph, right? So most of the applications are being now in transforming stage. I mean, they are transforming from one setup to the other setup, right? So first of all, you need to understand what was the oldest setup we are following while we building the application. I mean to say that it's a web applications, or I mean to say websites, like you have we have Netflix, we have Naukri. So we have a lot of websites what we have, right? So in the 2000s, right? So all the applications are of monolithic, right? So monolithic means everything. So if you wanted to develop any web application, what we have, we will be having front end, right? It means the HTML pages you have, right? And you also have the back end. I mean to say, any logic if you want to write, right? You should have some a coding style, right? Like Python, Java, right? So, and you also need to have a database, right? So these three are necessary to develop any web application. If I am saying the application is monolithic, it means that all these three are in single server. All these three are in single server. So that is a monolithic app. So there was a lot of disadvantages with the monolithic apps. Yeah, you can download Nirmala for now, but try to focus on the class, what I'm saying. I'm just talking about the application transformations, what is happening today, so that you'll understand the importance of Docker. So I hope you have understood this, what is monolithic app, right? So I'll just talk about what are the disadvantages if we are going for monolithic app. So if you see, let us take an example of Zomato, right? Most of you have heard of this application, right? So you might be using a Zomato. If I develop this application as monolithic app, it means maintaining all the code in one server will have a lot of disadvantages. Why? Because if something happened, and if the server is down, can anyone can access the application? Yes or no? Can I get some responses from you? So I'm just saying that if I am going for a monolithic app, I have to maintain my application code as well as database in a single server, right? If something went wrong and if the server is down, no one will be able to access the application, right? No one will be able to access the application. It means there will be a lot of issue for me, right? So because if Zomato is down, he will be using a lot of money, right? Because he will be not getting any orders, right? So to make the application live, so we have a lot of issues with that. So to make it as a modern app, we have to make into loosely coupled services. Okay, instead of maintaining this monolithic app, we have to make that application into a loosely coupled services. What we have to do is we have to separate the application into small services, right? So I mean to say small services means, for example, if you have Zomato, in Zomato we have food ordering feature, we have the payment feature, we also have tracking of your food order, right? So we have multiple features in a Zomato. So what we will be doing is that instead of deploying your whole application to a single server, we will make that application into loosely coupled services. It's called as a microservices. So this is what actually is nowadays happening. So we are not going to deploy the application to a single server. Instead of that, we will be going for loosely coupled services, or called as microservices. So here we are actually, the server was big server because the application was big, but here we will be having small servers for each and every service, right? So guys, can you just let me know, are you clear with what is a monolithic app and now what is we are doing? Can I get some responses, yes or no, in the chat? So if you just mention clear, I'll move for the next slide. Please do the chat. Yeah. So this is what actually app modernization is happening in the real-time industries right now, right? So now let me go to the other slide. So you can see, right, now what is app modernization? Instead of developing the application on a single code server, right? Single code server, what we are doing is that we are making the application into small chunks. You can see. So you can see your own, the front end part, the back end part, database, any other configuration, right? So instead of making the whole single application, we are making into small chunks, right? And we are developing that application. So this is what actually is the app modernization is about, right? Now we'll also understand some basics of how the applications are being deployed. So I'm just saying, right, I'm just saying that we will be making the application into a live one. So how it actually happens, right? How it actually happens. So this was actually a traditional deployment where you will have your own server, right? You will have your own server, the hardware. On top of the hardware, you have your own OS, right? Each and every server will have the OS in that, right? On top of the OS, we will install the applications, or we will be deploying the application. So this was the example of an monolithic app where we will be maintaining our application on a single server. So what was the demerits means? You can see, right? So in a single server, if you are hosting multiple applications, right? So for example, I just bought a server, right? And I'm running 3 websites in my single server, right? So as these 3 applications are used by the users, there might be a chance that for a single application, there might be a chance of much load, right? So then the CPU RAM, or you can say the processing of the CPU, will be utilized by the single application itself. So I'm just saying that to make it clear that if you have a single server and you have hosted multiple applications on a single server, what will happen is that, so these three applications are used by the users. There might be a scenario, a single application might get a lot of load, right? So, and with the, due to this, the other applications also will be facing downtime. Downtime means no one can access the application, right? So this was actual traditional deployment. So we cannot deploy multiple application on a single server. If you deploy, right, what is the scenario is that the depending upon the application, right? So if you have, if one application is taking more load or more CPU utilization, the other applications will be also down, right? So that's why the memory allocation is the major impact in developing or deploying the application. So is that clear? Can you once respond? That's why we will be not encouraging to use a single server to deploy multiple applications. But what was the scenario to use that, right? So how can I go and use a single server to run multiple applications? To do that, we have came up with one concept called as a virtual machine, right? So one second. Yeah, I have increased this one. I think I am audible to you, right? Yeah, thank you. So previously, right, I just showed you that there was not good usage of your RAM on the CPU, right? To make use of your hardware, whatever the setup you are buying, right? If you wanted to make use of the hardware, we have came up with a concept called as virtual machine. A virtual machine, nothing but it's a replica of your system. So whatever the system you're using, right? Sorry, one second. Whatever the system you're using, right? It is a replica. I mean to say, you have your own laptop, right? So if you wanted to create a virtual machines, what you require is that you have your own hardware, right? You might be going and buying a market that your laptop consisting of maybe a 1 TB of hard disk, right? 8 GB of RAM, maybe Intel 5 processor, right? So that is our hardware. On top of that, what you'll do, you'll install the OS, right? What you'll do, you'll install Windows or Linux. You might be installing anything, right? On top of that, if you wanted to create a virtual machine, you require a software called as hypervisor. With the help of this hypervisors, we can create multiple operating systems. So I mean to say that in your Windows machine, whatever the Windows machine you have right now, you can run multiple OSs on Windows machine, right? I can have one OS of Linux. Yes, VMware is the correct example of that. So VMware is actually providing the hypervisors for us to create the virtual machines. So that's what I'm saying, right? So you can see the one guest OS, and guest OS, right? You can see one we can have Windows, one we can have Linux, and one also we can have Mac, right? So we can have multiple OS on a single host machine. Yeah. Sahil, yeah, Oracle VirtualBox also is one of the example to create the virtual machine. So by creating this virtual machine, what is the advantage is that the RAM allocation. For example, I have around 6 GB of RAM of my hardware. Let us suppose, right? I can allocate 2 GB to each of the virtual machine. So previously, the major problem with the traditional deployment was RAM allocation, right? Because there is no restriction to an application to use only 2 GB, right? So a single application can take all the RAM. Maybe other applications cannot access the RAM, right? So that is what the scenario in the traditional deployment. But now in case of this virtual machines, what we have been achieved is the resource utilization. The hardware, whatever the hardware we are utilizing the them in a proper way, right? So now you can deploy multiple applications. Right? You can see now we have Windows, we have Linux, we have Ubuntu, let us suppose, right? Now this can have a single application. I can deploy one more application here, one more application here. Yes, we have to give that. So I hope you are now clear, right? So this was the thing with the virtual machine. So it is also reduced the production cost, right? So if I brought a good RAM with a good server, I can run multiple OSs on top of the server, and also I can maintain multiple applications. So guys, is it clear up to virtual machine? Now I have to go to the Docker concept, that is containerization. Can you once respond in the chat? Yes. If you're yes, clear with the chat, just mention clear in the chat. So virtual machine, we are actually creating multiple guest OSs so that we can so we can create multiple OSs and we can deploy multiple applications. Yes. So now let us go to the containerization. Yeah. So now we have a concept called as containerization, but we have to understand what is actually containerization is about, right? So guys, let us take an example of an application. Okay. So let us take an example of application. So you have developed the Flask application, right? So yesterday, maybe our colleague has been explained you how to develop the Flask application. So you have understood that. Now, if I wanted to run the same, if you wanted to run the same application on Linux or Ubuntu, is the same. Whatever the application you have been built on the Windows is the same, can be run on the Linux or Ubuntu. Or else I'll just frame the question another way. So for example, if you are installing a Docker in Windows, will have one procedure, right? You'll go to the Windows and you'll download the .exe file and you'll have to install that, right? If you go the same with your Ubuntu machine, you have to use the command to install. So I'm just saying that there is a OS restriction, right? So I mean, we are actually facing a lot of issues with the multiple OSs. So in the market, we have Ubuntu, Linux, we have Windows, right? So we have multiple OSs, and if you want to run the same Flask application, we have to require multiple dependencies, right? So the major dependency to run a Flask application is that we have to install the Python in the laptop. So once you install the Python in the laptop, you have to use some pip command to install the package, right? And the libraries, right? And then we have to run the application. Do you agree, guys? Can you once respond? I'm just saying that I have a source code. I mean to say I have a code of the application. To run that code, we have a lot of dependencies, right? We have to have Python, we have to install the libraries, and we also need to have install the path settings. So a lot of things are there to run a Flask application, right? To avoid all these things, the solution is that a common OS, right? A common runtime for the applications to run, right? So that common environment would be your containerization. See, containers are similar to virtual machines, but they have the relaxed isolation properties to share among the OS. I mean, these are all we can call them as containers. So these containers are similar to the virtual machines. I mean to say they also have the guest OS, okay, and they also have their own services, but they share the container engine. Okay, so I'll explain here. So just try to understand for now. Okay, so you can see, so we have the infra, right? We have the infra. On top of the infrastructure, what we have the OS. On top of OS, we have to install the container or the container engine. So here the container engine is Docker. I'm just saying that this container engine will provide the common OS properties among your containers. So here we will not call them as the virtual machines. We will be calling them as a container. So each and every application is a container. Hope you are clear. So here you can see they are easily portable and could work on any other platform. See, before that, what the thing was is if I wanted to run the Flask application, I have to install Python, libraries, everything, right? But now, when you make your application into an image or a container image, the only dependency what we have is the container engine, right? For example, I can say you in a simple way. I have developed the Flask application, right? I made my application into a container image. It's a package file. Now you want to run your my application onto your system, right? I can share the image with you. You only have one dependency is that you have to install Docker. As I am making my application to an image, right? It will run in all the containerized engines. Who will provide the container engine? Docker. I mean, Docker is a software. We have to download that and we have to install, right? With the help of the Docker, we will be getting this container engine to run our containers, right? Yeah. While deploying an application on device, we have to take keyboard device. Yeah, so it should be on, right? So I hope now somewhat you're clear with what is containers, right? So it's like we are making our application into a single package, right? So that it runs on all the container environments. So what is the container environment? Who will provide that? The software called Docker, what you have installed in your laptop, they will provide that, right? It will provide that engine to you, right? So now we will go for the next slide. So this is actually the overview. So this was the traditional deployment. This was the traditional deployment, and this was the virtualized deployment with the help of the hypervisors, right? And then we have the latest one. There is a container runtime, which is actually provided by the Docker, right? So we'll look into that. Don't worry about that. But I hope you're clear up to now. So now we'll actually see what is actually a container is about. I already told you that, right? So it's a way of package your application with all necessary dependencies and configuration. So you can see with all dependencies means to run my Flask application, what is my dependency? Python, right? If the Flask application is connected to any database, we have to configure, right? That is configuration. So if you are making your application into a package with all necessary dependencies and configuration, it is a container. It is a container. So those are portable. I mean, we can easily move them from one system to other systems and easily share and move, right? One of the other important thing is that they share the common OS kernel. They share the common OS kernel, right? And makes the development and deployment more efficient. So now we can deploy our applications in an efficient way because it is taking less time, right? So one of the thing is if you make your application with a container image, it is easy to move and it is easy to deploy, right? So you can see, yeah, so that's the major advantage of these containers. So maybe I will go to the next slide so that you'll understand in a more clear way. right? So you can see before containers, right? So for example, we have the developers, right? The developers want to install some Node.js or Mongo Express. I mean, this is the coding language and this is the database. If I want to install in Windows, I have to follow one procedure. If the same thing has to be installed on Linux, I have to follow different procedure, right? So which is taking a lot of time for the developers to run their applications, right? So that was the thing. Actually, you can see installation process was different, right? Yeah, yeah, it will share the same kernel, Varun, and the OS was the different OSs, right? This was the major issue, and there were many steps. If you go wrong, right, it automatically affects all the others. So I mean to say, installation was taking actually a lot of time for you. There is no need of Flask code. No. So once you create the Docker image, it's a final one. Okay, that's one thing actually. So you can see now after containers, what is the actual thing has happened? So we are making our application into a portable image, right? So where you have your own configuration, the thing, or you can say now you can just imagine your Python and the start script, right? Everything into a single package, right? Only one command is to install the app and run on different systems, right? So for example, if you have Ubuntu, if you have Windows, in Windows, you have developed the application, and with the help of the Docker, you have packaged your application with an image. And in your Ubuntu system, you also have installed Docker. There is no issues now because both are having the Docker. You just share the image to the Ubuntu machine, and you can run on the Docker engine. So we are making a lot of advantages while going with the containers, right? So now you might have questions, right? So now if I develop the application, how can I make or how can I access remotely? So before going here, can I get some responses about you're clear with the containers? So I want some responses, guys. Please do respond in the chat. Yeah. So thanks for the responses. Yeah, I'll brief that. So don't worry, guys. If you have some questions while we are doing with the practical, right, you'll get to know about it. Okay. So don't worry about that. So yes, Nirmala. I'll just show that also. We will be converting our the Flask application into an image. Okay. So now we can say so where we can store the images. So the end would be your image, right? So we have a container registry. So I meant to say once you develop the application, right, the code, you will be using the GitHub to store the code, or you can access the remotely, right? So similarly, once you create the images, you can store them in the container registries. So it's a publicly, we have Docker Hub. So it is a repository where we store our container images. Once we create the images, right, we can store in this Docker Hub. So if you wanted to store them in a private repositories, we are actually having a lot of clouds are actually providing a feature for us. You can see AWS ECR. So in AWS Cloud, we have a service called as AWS ECR. In IBM, we have IBM Cloud Container Registry, and we also have Azure Container Registry. So this is the services where we can store our images. So in your laptop, once you create an image of your application, you can upload them to this repositories so that you can use afterwards. Yeah. So now you can see what are the benefits if you're going for this key benefits of Docker container. One is the speed, because there is no OS boot in this one, right? The application will be live within the seconds. Okay, so that's a major advantages we will be getting if you go for a Docker container image. And portability, I just told you, right? So once you create the image and upload to the any of the repository, and you can access, right? It is easy to access that image again, right? So one is this, the second one is the portability and efficiency. So I mean, more there is OS factors are less, right? Issues with the OS and running of the application is less. So we can say it is more efficient if you're going for the Docker. Now we'll understand what is a Docker, right? So Docker is a platform that provides to package your application and run your loosely isolated environment called as container, right? So to run your containers, we require the Docker. We require Docker to be installed on your system. That is the Docker actually, right? So now we can see. So this is the client, and this is the host, and this is the registry. Okay. So now within your some commands itself, we can build the images, we can pull some applications, and we can run the applications. Okay. So I'll explain all the Docker commands. Don't worry about that. So I meant to say within fraction of seconds, we can build the application, we can pull that pull already built applications, and we can run the applications as well, right? And to run those things, right, we require the Docker host, so which will actually provides you the container environment, which actually provides the container environment, and you can run your images. So how can you get the images? From the registry. So what is the registry now? Docker Hub. One second, let me show you that. So this is the Docker Hub, guys. Okay, I'm just talking about a registry, right? I have told you here itself. I mean, in this slide, I have told, right, to if you wanted to store your images publicly, we have Docker Hub, right? So this is the repository where we can create multiple images and we can store them, right? So we also look into that. So now we'll see some Docker commands. I mean, so yeah, it's like a GitHub. Yeah, Purima, you're right. It's like GitHub. In GitHub, you will be storing your a source code, right? Whatever the code you develop in the laptop, you might be storing in the GitHub. Similarly, once you package your application into an image, we can upload that image to the Docker Hub and we can use remotely, right? Yeah. So guys, now we'll see some commands. Okay. So you have understood what is Docker, right? Somewhat you have understood. Now we'll also have some hands-on on Docker. How can we run some application on Docker, and how can we pull some images? Okay, so we have a lot of images in the Docker Hub. I'll just show you something. Okay, so I have requested you to register an account. Can I get some responses? Have you done with the registrations? So I'll also share this link again in the chat. I have requested you to register here. Please do that. So if you want to install Docker in your laptops, so one second, I'll show you. So you have to use Docker Desktop for Windows. So this is how we have to install. You can just follow the procedure to install Docker in your laptops. Okay, so but it will take a time for you to install. So instead of that, we have a service called as Docker Playground. Yeah. Nitin, registry is nothing but what? See, I'm just saying that your Flask application, right? So whatever the application you have built yesterday, if you wanted to make them a Docker image, once you create into a Docker image, you have to store, right? If you want to store in the cloud platforms or remotely, like GitHub, right? If you want to store them remotely, we have a Docker Hub. It is a registry or repository, you can say, right? So here we can upload our Docker images. I hope now you're somewhat clear, right? So guys, you can install the Docker later, but I'm also sharing the link in the chat. Yeah, so in the chat, I have shared you the link. Okay, so with the help of this link, you can download the Docker desktop and just follow the procedure and install Docker. Okay, that you can do later part, but now we'll have some practical with Docker. To have the practical, right, you need to open this Docker playground. So I request all of you to just search for this Docker playground, and you have to open this labs.play with docker.com. So I'm just sharing you in the chat. Just open that. So can I get responses, guys? If you have opened, kindly respond this in the chat so that I'll start how to log into this one and how to create an instance for you. And we'll see some Docker commands, and we'll try to pull some already developed applications, and we'll see. I just want some responses in the chat. Once you have opened this one, put some S in the chat. Yeah, thank you guys. Thanks for the responses. Now we'll see. I hope most of you have opened this one, right? So you have to click on start. Click on start. So you will be getting this kind of screen, or if you're getting login with Docker, you have to log in with your Docker Hub account. Right? I mean to say, I'll also show you here. 1 second. If you just use Docker Playground, right? So if you just click on login. So here, right, if you're getting login button, use Docker, and you have to provide your email, right? So email or your username. Click on here and give the password, right? Provide the password and click on continue. So once it is logged in with your Docker Hub account, click on start. Yeah, I'll stop this one. 1 second. Right? So I have just showed you. Right? So can I get some responses, guys? I've done up here. So I just wanted to show you, see, once you also install your Docker in your laptop, right? This is the same environment you'll get. Okay. So now once you have opened this one, right? Once you have opened this one, click on add instance. Click on add new instance. Click on add new instance. Bhavishya, you have to click on Docker login and you have to use your credentials. Just try to refresh the page, you will get, okay? Just try to refresh the page. So they will be giving some virtual machine to us, okay? So with the help of the virtual machine, it also already have a Docker inbuilt install here. So you need to install Docker. So you can directly use the Docker commands and you can work on here. So can I get some responses, guys? If you are done up here, kindly respond in the chat. Right. So you can see, right? If you want to use these credentials, if you want to use this console, you can use, or else you can just copy this SSH copy. You can see SSH IP and this one, right? You can just copy this one, open your command prompt just paste that command. Click on connect. So I mean to say you can work here in the browser itself, or you can connect this one from the command prompt. Yeah. So Anusha, once you have got the screen right, click on add instance. Click on add instance, you'll get this window, right? So guys, you can also work here itself. I mean, you can just type here, but you don't want to do it here. What you can do is just copy this command, the sh command, copy that. What I have said, just open your command prompt, paste the command, click on enter. It will be connected to the same instance. Whatever you are observing here, right? It will be the same, right? People, can you once respond? Are you able to connect from the command prompt? So guys, let me know. Okay, so no issues. Fine. If you're getting some issues, okay. So we'll use the same not required actually. Fine. It's fine. So we'll use the same here itself. Okay. So now use Docker, right? And click on enter. Right, you can see this is a Docker command, right? So Docker has been installed in this machine, right? So now, one second, let me clear. So you can use a clear command to clear, right? So what I'm saying is that, so you can run any application, right? But only the dependency you require is Docker. So now I'll show you already developed applications and converted them into a, yeah, Pradeep, you can deploy the ML models using Node.js. You can do that once you can, if you build your Docker image. So just open Docker Hub. I wanted to deploy some applications. You can see, right? So this is a Docker Hub. So there are a lot of people or a lot of developers who have been developed the applications and made their application to a Docker image, right? So let us search for that. So let me UI some Flask. So I'm just using some image. Yeah. So I am sharing this link in the chat for you. Yeah, I'll explain. Don't worry. I haven't done anything. Okay. So I have just shared some link in the chat, right? Link in the chat. So this is some of the applications someone has been developed 6 years ago, right? So I'm just taking this example for you to explain you the Docker importance, right? Now I wanted to run this application, right? Because he might be used the Flask only, right? Flask only to develop the application, and he have made that application to a Docker image, right? So you can see we can pull this image. I can download this image from the Docker Hub with the help of this command docker pull, and this is the image name. This is the image name, right? This is the image name. So I can copy this command. Now come back to your Docker playground. So you can see in a single step, okay, we are getting the code, right? So what you have to do is you have to click on the commands and use Control Shift V. Control plus plus v. So this is the thing you have to use to paste the command docker pull, and you have to paste the command and click on enter. What will happen is that it will pull the image from the Docker hub. It will pull this image from the Docker hub to the playground or our instance. Guys, can you please once let me know, are you able to pull that image? So you have to copy this one, right? Come back to the playground, click on the cursor, use Shift Control V. You cannot directly use Control V to paste here. You have to use Control Shift V. Right? Guys, please respond. Are you able to do it? I'm just waiting for your responses, guys. Yeah, thank you. Right. So once, right. So now, you know, you have done pulling, right? So now to run that application, to run the Docker image, we have some command here, Docker run, and with some port, right? We have some command, right? Just copy this command as well. Copy this command, Docker run, and use again Control Shift V to run that application. So you can see Docker run -d. We have given some port, right? So you know, right? Yesterday the Flask port would be the default port would be 5000. You can also use the custom ports, right? So he is actually using 9000 port to run that application. Paste this one. Click on enter. Click on enter. So automatically you can see something 9000 port is been on your screen, right? Just click on this 9000 port. You will be able to access the application. So this is what the application. So in a single command, we are running the application. So there is no need of Python, Flask, everything. That is no need. The only one command to pull the image. The other command is to run the application. So it is simple, right? So instead of getting the code and everything, right? So as it is a container image, in a single start, we have able to get the image to our playground, and we are able to run that. And we are also able to access the application as well. Is it clear, guys? Guys, can you please respond? Are you able to do it? I'll explain what is happening, but give me some responses that you are able to pull the image. Okay. So I'll just share you this command. Yeah, I also shared the command what I have run in the console, right? In this console, Srinidhi, I am able to get you. So this is the command to pull. Pull is the command to get the image from the Docker hub, and the run command is to run your Flask applications. It's not only Flask, any applications. Right? So let me clear. So are you clear with Docker pull command, guys? It's only to use to get the image from the repository, right? Yeah, I have showed you one. I think you can see, right? So once you have been run your application, you can just click on this port 9000, and you're able to get the application access. So guys, can you please share your links on the chat? This link, I'm asking you to share these links. Once you are able to access your application, share that links in the chat. Yeah, I think Nitin, some people are sharing. I'm sticking on one of the link. Yeah. So this one is one of some application from your team bits, right? So this is how we actually run that application. So the installation process is not necessary in your Docker, right? So once you have only the Docker environment with you, right? So we have having a Docker install here. That is why we are able to deploy, right? So to make you more clear, right, on this topic, I'll go with some more commands. Like you can see Docker space PS. So you can see Docker space PS means PS is process state. Nirmala, I cannot get you IP 172 command, how to get that. So can you please reframe your questions? Yeah. So what I'm trying to explain you is that this one you're asking about. For this, I haven't done anything, Nirmala, from the playground itself. So you can see this one. I think there is the link actually, right? So this is the link. It is being generated for us to access the application, right? So the playground is giving the access of your link. Okay. Yeah. So to check what all the images or what all the containers are running in your Docker engine, you have to use Docker PS. So you can just use again Docker space PS is a command to get the containers what are running in your Docker engine, right? Now, if you want to stop the application, you have got how to run that, right? So with the help of this, help of this Docker run command, you are able to run the image. If you want to stop the image, if you want to stop this running application, we have a command. So let me show you that. So let me first of all use Docker PS. So this is the application running in my Docker engine, right? If I want to stop this one, I have to use Docker space stop space, and I have to provide the container ID. Save that container ID and use Ctrl+Shift+V. Just 1 second. Just use Docker PS to get the container ID, right? You have to use Docker space stop space. You have to type this container ID. You can see CC 66D 36 C1 5 F5. So you have to use the container ID to stop your container. Click on that. So you can see as a response, you'll get the container ID. To stop your running containers in your Docker engine, you have to use Docker stop, and then you have to use container ID. You have to use container ID. Now, if you go to the UI and if you refresh the page, 1 second, you can see maybe with the same link, right? I was able to access the application, but when I stop my container, right, with the help of this Docker stop command, so it is not able to access because the application is down. I just tried to copy Nirmala, but it's giving some error. Just try to type it, right? Simple word, right? You can also use Ctrl+Shift+C and you can use that. So we have just covered few commands. One is a Docker pull command to pull the Docker images. We have used Docker run command to run your applications. And we also used docker ps command to see the process or to see how many containers are running, and we use docker stop command to stop the container. Now, if you wanted to remove, if you wanted to see what all the images are there in your Docker, you have to use docker space images. You can see with the help of this docker space images, we will see what all the images we have, right? What all the images we have. You can also remove this image as well. If you want to remove this image, you have to use docker space RMI, and you have to provide the image name. One second. One second. You can use RMI, and you can use -F is for force stop. Second. One second, guys. I'm just trying to clear. Use docker space images, which will actually show you all the images of your Docker engine. And if you want to stop that image, or if you want to remove that, right, you can use docker RMI remove image. You can just use -F for force remove. You once again, I'm just typing that UFID /UI for so you'll get this one. Okay, so you get this untagged one. So that means you have deleted that image. So if you want to check again, you can use docker space images. There will be no image. Is it clear, guys? Can you please once respond in the chat? Deleting of an image. So I just showed you how to pull the image, how to run that, and how can we see what all the processes are running in that, and how to stop the container, right? So image is the package file which is not running. If the image is running, that is called as a container. Okay. So I also showed you how to delete that using this docker RMI. Yeah, you can just try that. Yes, you can just try with that image ID. So I hope till now you are clear, right? So can I get some responses, guys, if you're clear up to here? Yeah, that's what I'm saying. So you have to use this force image to delete. If you're not using this -F, right, you'll get error. So it is not giving permission for us. So I'm asking you to use -F to force delete the image. Fine. So I hope you're clear up to here, right? Right. So now we'll clear this one. Right. So thank you, guys. Thanks for the responses. Now let me go to here to my Docker Hub. So let me go to my Docker Hub. So already I have made the Flask application to a container image, right? And I have uploaded to my Docker Hub. You can see, right? So this is my login, right? And in my login, I have pushed this image. Now I request you to pull this image. I'm pasting my image name in the chat. I have pasted my image name in the chat. So what you have to do is you have to go to your playground, the Docker playground here, and you have to use Docker space pull space and use Control Shift V. This is my image, right? Sandeep Dudikani / Sandeep Plasma. Some name I have given to that. So already I have developed that. Now it is easy for us to pull and run, right? That is a major advantage of Docker, right? So just click on this enter, it automatically pulls, right? So I'll explain how the image has been developed. So don't worry about that. So now you can see there are a lot of pulls is happening, and it is pulling all the files which is required for the image. And you can see that image has been pulled, right? So guys, are you able to do the same thing? Are you able to pull the image of this one? Kindly respond, guys. I have shared this one in the chat, the image name. The only thing you have to do is Docker pull, and you have to mention the image name, and you will be able to pull the image, right? So you can see has the image is been public. This is image is public. You are able to pull. If it is private, you cannot pull the image directly. You require the login credentials to pull the image. So guys, I want others to respond. Can you please respond, guys? Are you able to pull the image? Right. So what you can do is you can just use Docker. You can use Docker images. You can see the image, right? So previously, if I use I have used Docker space images. There was no images, but there is now an image. Now tell me, how can I run this an image? What is the command I have to use, guys? Can you please tell me in the chat? Yes, thank you. So Docker run command, right? So you can use Docker run, right? Docker run -p. So P is the port what we have to define. So I'm just defining the port of 8080, right? And then I have to give the image name, right? Control Shift V. So to run the Docker run command, you have to use Docker run -p, and you have to provide 8080 port and give the image name. Click on enter. You can see now the Flask application is running, right? So only two commands. One is the Docker pull command and one is the Docker run command to run the applications, right? So now you can see again port 8080 is on, right? You can just click on this link. This is the Plasma app. So you can see check register home, right? So in 2 steps, we are able to run the Flask application, that is the Plasma app. So you can see everything is similar to your Flask, right? Guys, can you once respond? Are you able to do the same thing? What about others, guys? Can you respond? I'm just waiting for your responses. If you respond, I can continue. Or if you are not clear with any topic, let me know. So once you have run your Flask, the container image, click on this 8080 port it will load the URL and you will be able to access the application. Right. So now I'm just, you can use Control C to stop that application. Control C. Here you have to use Control C to interrupt your application. Now use Docker space images. Yeah, you have your own image. Just clear in this console. Now tell me how to delete the image in the Docker. Yeah, thank you, Nirmala, for that. Right. Thanks, guys. Thanks for the responses. You can use Docker space RMI. Okay, let me first of all get the image ID, right? Okay, Docker space RMI -F, and you have to use the image name, right? So when I click on enter, right, the image will be deleted. Now we can use Docker space images, sorry, images. There is no image now, right? Yeah. So guys, I hope you're clear up to here right now. If you're clear with some Docker commands, now we will see our Flask application. We'll go back to our yesterday's class, what you have been taught to you, right? I'll explain you how can I containerize the application now, right? So, but I want some responses, guys. So thank you, Nirmala. Thanks for that. So what about others? Can you please respond, guys? So now I'll go back to our Flask application. Yesterday, what we have done, right? We have built you the Flask application that is Plasma, right? So let me go back to the Plasma app. So this is the application what you might have been built. Yeah, it's fine, but just try to understand, Nirmala. Okay, so this is the Flask application, right? So I'm just opening the command prompt, right? So I'll just run the application app.py. I'm just showing you the output of the application. Okay, so before we converting the application of an image, I'm just showing you the application. Okay, so let me go to the browser. Okay, I'll remove all these tabs. If I use localhost 8080, you know, right? It's locally application. It's a local application I am running, right? So now you can go to the register button, home button, right? So everything I can access, right? So to make this application into live, so this, I mean, right now we haven't made it to a Docker image, right? It is a simple application which is running from the Python environment. So you can see I have Python in my laptop. So with the help of the Python command itself, I'm running the Flask application. It is not a Docker image yet now. I'll show you how can we create the Docker image. Okay. But you can see, you can click on register and you can use a name like Nirmala something and Nirmala@gmail.com. And I can provide some numbers like 1, 2, 3. I'm just giving some number and some city, infected or uninfected, 182, something. I'm just giving some data and some password, right? So when I click on register, right? So you'll get this registration successful. It means we will be storing the data in the IBM DB2 service. If I refresh this page, already have logged into the IBM cloud. You can see, right? The data what I have entered, it is into the database, right? So everything has been done. So application is running perfect, right? But now to make the app modernization concept, we have to make our application into a Docker image, right? To make that Docker image, first of all, we need to specify the dependencies, right? So I mean to say, if I open my code, so I have to have a Flask is one of the dependency I have to install. I also require IBM DB is a library, right? To make this one to work, so what I have to do is I have to create a file called as a requirement.txt file. Require requirements.txt. This is the file I have to make. This file, right? Here I have to mention the Flask is my dependency, IBM underscore DB is my second dependencies. So we have to maintain this file, right? So these are all the things I have to do. Now, if I wanted to make this application into a Docker image, we have to write some file, that is a Docker file. So we have to create a Docker file, because I have to use some file to make this application to Docker image, right? So we will use a Docker file. So we have to create a Docker file here. And with the help of this Docker file, we will have to create the image. Okay. So to make the image, I also require Docker Desktop in my laptop, right? I have that. So let me open my Docker Desktop, which is also already installed in my laptop. So I'll just click on Docker Desktop. So it will run in the backend. Okay. Meanwhile, what I'll do is I'll create the Docker file for you. I will create a Docker file for you. So I'm just creating a new text document. I'll open this text document with Notepad++. Give me a minute. I'll just show you. I'll write some code here, but don't worry. I'll explain what I'm writing that. Okay, so please wait for that. It is taking some time. Please bear with me. So you have to write this code. That is, so I'll just, one second, I'll just copy and paste the code here for your signing. I'll explain the code. 1 second. Give me a second. Yeah, so here this is the code actually you have to write. I'll explain this code, guys, but please bear with me. So to save this file, right? So click on File, Save As. Let me save the file. I'll explain what all the requirements I have written in the file. So 1 second, it is saving the file. Yeah. So you have to save your Docker file as a Docker file. So there should be no extension, guys. one of the things is you have to mention it as a Docker file and click on save. Click on save. So if you go back to the folder structure, right, of your Flask application, one second, go to your folder structure, you can see a Docker file. So there should be a requirement.txt file and a Docker file should be there in your folders. So this is the file. I'll explain now what I have written here. So let me go back to the Notepad++. So you can see from Python 3.6. So I'm just giving you the base image of your container. That is, we require a Python 3.6 version, right? And after that, in the container image, we are creating a directory, and the directory name would be app/app, right? And we are adding all the files to this app. I mean to say, this all the files will be added to a folder called /app, right? And then we are copying all the requirement.txt file to the app folder itself. Once you have done that, with the help of this run command and with the help of this Python 3, right, I am trying to install all the dependencies which are present in the requirements.txt file. In this requirement.txt file, we have written these two dependencies, right? One is the Flask, one is the DB, right? Those will be installed on your container. Those will be, one second, guys. Those will be installed in your container. This is the container, right? This will be installed. And with the help of this Python run command, we will actually install the IBM DB as well. And we are also exposing some port, that is 8080 port. And we are running the application. Once the container is live, we are running the Python app.py file. So, I mean, we are doing all the procedure in an automatic way with the help of the Docker file. With the help of this Docker file. So with the help of this Docker file, we will actually create the Docker image. Okay. So I'll also show you that, one second, if it is live. Yeah. So now you can see my local Docker desktop is live, right? So I can use this Docker desktop to create the Docker image, right? So let me show you how can I create the image. If you open the command prompt, the local environment, you have to use Docker space build command, Docker space build command, and you have to use -t is for tagging of your image. I'm just giving plasma, right? IBM hack. I'm just giving some name and provide space and click on dot. So it means if I give the dot means it will take the Docker file, has a source file, and it will create the Docker image. So let me click on enter. So you can see it is taking all the files. You can see, right? It is creating a Docker. It is first of all taking the 3.6 because I have mentioned that in the 3.6 in the Docker file. And later it is creating the app.directory. Then it is adding all the files to that. And it is running the requirement.txt file, right? And then it means it is installing all the dependencies which are required for the application to run. Right? And it is collecting the Flask, you can see, right? Now I have mentioned, right, in the requirement.txt file, I have mentioned the Flask one, right? It is also pulling that Flask image. And it is taking some time to create the image now. It is creating the image. So your application will be made into a Docker image. Yeah, it is taking some time for you. It is creating the image. Once the image is created, I'll just show you the locally. Okay. So please be somewhat patient. So once the image is created, we can also push this image to your Docker Hub. So previously I've shown you, right, the image what I've pushed it, right? So similarly, we can also push the same image to the Docker Hub. Okay. But let me, first of all, it is building still. So it is last step to build your images. Yeah, it is exporting the image now. So once the image is exported, right? So I'll show you that. So using the Docker image command, I'll show you the image which is created in the my local Docker desktop. So now you can see, right? It has been now done. So now if I use Docker space images, this is the image name what I have given, right? You can see that image. You can see, right? So previously I was actually running the Flask application, right? This is the Flask application, right? I'll just stop that one now. I'll just close this command prompt. I close this shell as well. Now only I have Docker. So now the image has been created. If you want to run the Docker image, you have to use Docker run -p is the command, right? 88 is the port you have to give. And you have to use the image name. It is Plasma IBM hack. So I'm just showing you that once we create the image, we will actually test that image in the local environment only. Okay, maybe the library, one library is missing here. That's why we got error. That means here itself, maybe here. This is a library actually we have in that one, right? So maybe I missed in this requirement.txt file. So we have to mention that as well. So if you save this one and rebuild your image, you'll get that. So I mean to say, you have to use Docker space rmi-f and provide your image name, delete the image, and if you build it again, it will work. Okay, so that's how we actually create your images. Okay, so from your Docker images. So I have just show you converting of your small Flask application to your Docker image with the help of the Docker file. If you write this Docker file, it will actually create a Docker image for you. So in this, what you will be having in the Docker file is that all the dependencies are necessary packages to run your application. You know, right? So we require Python, we require the files, and we also require the port and all this stuff, right? So once you have built your Docker image, right? So it is again building for us. Please give some time because it is has to build all these things. So your Docker file would be file. There will be no extension, guys. Don't give docker.txt kind of stuff. Your Docker file is a file format. So you should not give any extension over here. It is not txt and all this stuff. Okay. So now once image has been built right, use Docker space images and use the same run command to run your Flask application. So you can see now you are able to run your Flask application. So previously I have missed one library, that is a request library in your requirement.txt file. As it is not installed, we have got the error. Now if I go to the browser and if I use this local host login, you will be able to access the application, right? So guys, are you somewhat clear with this creation of a Docker image from your Flask application? Can I get some responses? If you have any questions, you can ask me, guys. So I've just showed you, yeah. How it is created is that, so we have some instructions to be written here. In your Docker file, you have to write some instructions, right? And based on your instructions, you will be actually creating a Docker image of your application. So whatever others, guys, only have received few of the responses saying yes. Whatever others, you are clear. I just want you people to understand, we will actually create the Docker images for your applications. Is that clear, right? Yes, Nirmala, I have cleared that. So guys, now I'll be going to the next topic, right? So hope you are somewhat clear with the Docker and creating of images of your applications. Now let me go to the deployment. Okay, so if you want to deploy some applications, right? So we have a service called as OpenShift. Yeah, I'll share you the GitHub. Give me a minute of time. I'll be sharing you I'll upload the code to the GitHub and I'll be sharing you the link. Okay, so let me quickly talk about this introduction to OpenShift part. So I mean, what is an OpenShift actually and what we can do with this OpenShift. Okay, let me talk about sometime with this one. Yeah, so somewhat it's like IBM cloud only. We can deploy our applications in OpenShift, but how? So let me first of all talk about what is an OpenShift, right? OpenShift is a platform as a service. It is a PaaS service. So they have a built this OpenShift platform as a platform as service, and which was actually developed by Red Hat, right? So Red Hat is the company which has actually developed this OpenShift, right? So it provides a development environment on-demand service. So whenever we require the service, right, we can create this one and we can deploy our application. It's a self-service as well, right? And this OpenShift also provides multiple language supports, right? You have C, I mean, you have Python, Java, Node.js, right? So we have plenty of languages, right? And frameworks. It provides all the runtimes and all the databases to run your applications. And the next thing is you can also automate your life cycle. Life cycle of your application. How we have created a Docker file, right? So we can also automate all this process with some automation tools what we have in this OpenShift. And it also enables the collaboration between the developers. I mean, we can have the collaborators for the OpenShift and they can work on the common environments, right? And let me now move to the next slide. So why we have to go for OpenShift, right? So as I told you, it's a self-service. We can deploy or deploy into our own premises. It also have multi-language support. You develop in any of the language. You have a deployment environment provided to you to deploy your applications. We also have an automation tool to automate the process of your application deployment. I also told you that we also have a collaboration for the team to build applications in a group, right? So we also have multi-tenant. We can also have multiple clouds to deploy, and it also have a web scale. I mean, you can scale up your application easily, and it is an open source. We also have open source as well as enterprise, right? And we also have a security provider for this OpenShift. I mean, OpenShift will provide the security for your application as well, right? And you might have a question that where OpenShift fits, right? It might be in your development process, right? It also provides you the IDE or environment to develop the application. Like if you're going for any waterfall model, agile or DevOps, it will provide you it will be fits on you in that process, or in the application architecture. I mean, we can deploy a monolithic app or any entire application or microservices, right? So it also fits into that environment. And deployment. So I mean, you can deploy this OpenShift onto your normal physical servers or virtual servers or cloud or containers, right? So it can be hosted. I mean, it will support all these kind of things. And you can also deploy this OpenShift into your own data centers or cloud. So this is how actually OpenShift works, right? So if you see the architecture, right, of the OpenShift, what we are providing to you. So you can see a developer will develop the application and they will push their code to the GitHub, right? So, and this is the OpenShift platform. It's a PaaS platform, I said, right? And we have a master node. Whenever you deploy your application onto the OpenShift, we have each node for the application. And each node has its own runtime, right? It has its own runtime. And you can deploy your application onto the nodes, right? So, and each node has its own multiple varieties of language support. And it has its own storage, persistent storage. And you can also get the publicly accessible URLs with this routing layer, right? To be more clear, right, I'll be going you to deploy some applications into the OpenShift Red Hat. Okay, so let me show you that. So to have an account, right, in the OpenShift, you have to use Sandbox, OpenShift. So click on this developer Red Hat one. So to deploy your applications, right? So they are actually providing you the 30 days trial to you, right? So you can just click on start your sandbox for free, and you have to register an account here with your personal email ID, right? And once you register, right? Once you register your account, you can log into this Red OpenShift. Okay, so now let me log into my account. Just open this website. So I request you to register. One second. Just use Sandbox. And click on this link, developers redhat.sandbox.com. So I'll share this link in the chat. So just click on this start your sandbox for free. Click on that, and you have to register for a Red Hat account. You have to fill this form, right? So once you fill this form, you will get an email. You just to verify that. Okay, just you follow the procedure, guys. You will be able to register an account. For now, what I'll do is I just log into my account. So you can just follow the registration process and register an account. So once you click on that, right, you just need to use get started in the sandbox. So just click on get started with sandbox. So when you click on that, right, you will be actually opening your Red Hat OpenShift dedicated, right? So this is the website. You'll get this one. So once you create, so you have to use this dev sandbox login. Once you create the account, you can log in from here. So once you have been logged in, right, so you'll get this kind of console. So where you can see add, topology, observe, right? So they are actually providing the environment to you, right, to deploy your applications. So I will be showing you a sample app deployment. Okay. So 1 second, let me go back to my code. So if you click on your sandbox, right, to deploy your application, so click on add. So you have plenty options. I mean to say, you can deploy your container images, or you can also deploy your the code. If you have any code from your GitHub, right, you can also deploy from here. But now for time being, I'm going with this container image pull, right? I'm just clicking on container images option. You can see you have to provide your image name, right? You have to provide your image name. If I go back to my Docker Hub, right? So I already have image. This is the Plasma application image, right? Which is actually I've built, right? I'll just copy this image name. I will just copy this image name. I'll come back to my OpenShift Red Hat, right? Just to paste that image here. It validates the image from the Docker. I mean, it will pull the image from the Docker Hub, right? It will validate that. And you can see, you can also name your application name and the resources and the deployment stage and the port, right? So once you click on this create, right? Once you click on this create, we are actually deploying our application image to the Red Hat OpenShift dedicated, right? Just click on create. So you can see now actually, if you, this is the image what I'm trying to pull, right? If you click on this one, and if you go to this logs, view logs, you can see it is actually pulling this application, right? So from the Flask application is pulling, and if you wanted to access the application, you can go back to the topology. So click on this link. You can see your Plasma application. So the main point what I wanted to say you is that with the help of this OpenShift dedicated, we can deploy our application and make our applications live. Is it clear, guys? Can you please once respond? So guys, can you please respond once in the chat? So my purpose of telling you this OpenShift is that you can deploy your applications onto the OpenShift dedicated and make your application live. I'll share this link as well in the chat. So you can just click on the link and you'll be able to access the application as well. So you can register this one. I have just told you, right? So you have to follow the procedure to register an account. So we'll also share this procedure in the Telegram group. You can follow that and you can register an account. And once you register, right, you can launch this Red Hat OpenShift and you can work on that deployment of your applications. Guys, I'm just expecting some answers. If you're not clear, please ask some questions. I'm ready to clear your doubts. Guys, any questions you can ask me. Yeah, what I'll do is I'll just share this code to you. One second, let me. I just create a repo and I'll share you the code of this one, the Plasma application, so that you can work on the app. Right, so let me upload the code and share it with you. So I'm just uploading all the files and I'll be sharing you the Flask application code with you. You can create your own Red Hat OpenShift accounts, right? So once you create that, you can use this link to create the applications. I mean, you can create the Docker image and you can deploy the app. So are you clear with the Docker part, guys? Can you once respond about that part at least? What I'll do is I'll just share once it is uploaded, right? I'll be sharing you this the GitHub link. in your Telegram group itself. Okay, so you can just take from there. So any questions about your Docker or any other things, right? So you can use. So I have a question. Sir, can you use GitHub Desktop? Yeah, I haven't installed that, so I have to install it. That Muhammad. Okay, maybe issue with the Zoom, Nimla. Yes, yes. That's a good question. So you can see while I have signed up on Docker, I have seen Ubuntu. Yes, Ubuntu is also an image, but I don't know the name. Anonymous, it is an image. Yes, we can also have images of our OS as well. Okay. So it is processing, guys. Meanwhile, the people you can ask me. Yes, Sandbox is free to deploy your applications on web, but it is only for 30 days. Okay, it is only for 30 days, guys. Sandbox is free for 30 days. You can just create an account and it is providing you the OpenShift dedicated. So the software, I mean, you can just see this one, right? The OpenShift dedicated, it is a site. OpenShift dedicated is the software what we have to deploy our applications. Yeah, Varun, that's what I'm saying. You can find all the images on your Docker Hub. Okay, so it's an image. So yeah, it's still loading, guys. No issues. I'll be once it is uploaded, right? I'll be sharing you the code in the GitHub. So any questions, guys? Yeah, if you're clear up to here, just mention clear. I will wind up the session for today. Yeah, you can deploy the Docker image on other platforms like AWS. Yes, you can deploy. Yeah. So I mean, we also have talked. I have told you about AWS registry, right? So you can deploy those applications on AWS as well. Any other questions, guys? I'm expecting questions. You can ask me in the Q&A. I'll help you with the answers. So I hope it was somewhat clear to you, like what is a containerization and how we have made our application to a container image. And I also told you that you can also upload this container images to your Docker Hub, and you can remotely access your images, right? And also later on, I also explained about what is an OpenShift, right? And OpenShift dedicated. And I also shared you the link to register. So once you register, you can launch your OpenShift dedicated, and you can also deploy your images, right? So once you containerize your image and once you deploy it into your image, right, you can deploy. We can also deploy our Git code. I mean, once you push your code to your GitHub, right? Let me show that as well. So if I have already links, right, let me show you that. So for example, this is my code, let us suppose, okay? So you can also deploy with the Git link, right? So if you go to directly to your OpenShift dedicated, go to add button. So instead of going for the image, right, you can now go with the Git repo. So click on import Git repo, and you have to provide your GitHub URL. That's it. It will validate that, and it will create the, 1 second, you can deploy your application. It is simple. So you can go with your images from the Docker desktop, or you can also directly deploy your source code. But it should have a Docker file in it. If you don't have a Docker file, you cannot deploy your application. It will take the Docker file as a source file and it will deploy. So So that's what Mohammed, if you have a Docker image, right, it will be easy to run your application. So instead of installing all the dependencies to run your app, it is a simple way of packaging your application and running your application in a single shot. Yeah. So thank you guys. Thanks for joining. And I hope you are clear with this session, right? And you have got some idea on Docker and some idea on OpenShift. So thank you guys. Thanks for joining. Have a good day.